Welcome to my YouTube channel Statisticians Club. I hope everyone is fine. Please subscribe the channel. Also press bell icon to receive latest videos about regression analysis and econometrics. In last lecture we discussed method of least square. In this lecture we derive the formula of intercept and slope of the regression model. Here we discuss simple regression model yi is equal to beta 1 plus beta 2 xi plus error term. Here in this model yi represent the dependent variable, beta 1 represent the intercept, beta 2 is the slope, xi indicates the independent variable, and epsilon naught represent the error term. According to least square criteria, the residual sum of square is if we find the residual, take both these terms to the right side, and as you know, when term go to the other side, sign will be changed, yi minus beta 1 minus beta 2 xi. So we can rewrite it as error term epsilon naught is equal to yi minus beta 1 minus beta 2 xi. So this is our equation number 2. In the next step, summing this equation ends by taking the square, so we can get this equation squaring error term plus sum is equal to sum of yi minus beta 1 minus beta 2 xi square. So this is our equation number 3. In next step, for the purpose of minimization, we partially derive equation number 3 with respect to intercept and slope. As you know, beta 1 is our intercept here and beta 2 is the slope, and then equating the final term equal to 0. So we start first with partially derive equation number 3 with respect to interceptor. So partial over partial beta 1 sum of ei square is equal to partial over partial beta 1 sum of yi minus beta I minus beta 2 xi square. According to power formula of derivation, we write 2 here and 2 minus 1, and then partially derive the term inside the bracket. Partial over partial beta 1 yi minus partial beta 1 over partial beta 1 minus partial over partial beta 1 per beta 2 xi. As you know, in partial derivation we derive with respect to partial beta 1, so other terms instead of beta 1 are considered to be constant, and the derivation of constant is equal to 0. So here the derivation of this term is 0 and this term is also 0, and by dividing this term with this term we get minus 1 here and now we complete our derivation equating this term is equal to 0. So here is 0, and when 2 goes to the right side, 0 over 2 is equal to 0, and we multiply this sum and minus 2 into the bracket. So we get this equation minus sum of yi plus sum multiply to intercept n of beta 1, and this minus plus, and this minus plus beta 2 sum of xi. We can write this equation as when this equation go to other sides, this minus convert into plus. So we write is as sum of yi is equal to n beta 1 plus beta 2 xi. So this is our first normal equation, and we give to number 4 here. And now deriving partially taking partial derivative of equation number 3 again with respect to slope. So partial over partial beta 2 sum of ei square is equal to partial over partial beta 2 sum of yi minus beta 1 minus beta 2 xi square. So again use the formula of power. We write as 2 sum of yi minus beta 1 minus beta 2 xi 2 minus 1, and taking the derivative of the term inside the bracket, partial over partial beta 2 yi minus partial over partial beta 2 beta 1 minus partial beta 2 over partial beta 2 xi. So we discussed previous because here we driving with respect to beta 2, So every term other than beta 2 considered as constant. So here this is that the derivation of constant is 0. So here is also we obtain the answer of 0, and here is also 0, and divide this term partial beta 2 with partial beta 2 1, and minus xi we obtain here minus xi, and 2 minus 1 1. So write this term as, and 2 sum of yi minus beta 1 minus beta 2 xi and minus xi. Equating now we complete our derivation with respect to now we complete partial derivative with respect to slope, and now equate this term is equal to 0. So 0 to 0 over 2 is equal to 0, and now multiply these terms into parentheses with minus sum of xi, minus sum of xi. So we obtain minus sum of xi yi plus beta 1 sum of xi plus beta 2 sum of xi square. These minus convert into sum when multiplying this. So the equating the equation equal to 0, we get sum of xi y is equal to beta 1 sum of xi minus beta 2 sum of xi. We replace beta 1 beta 2 by their estimates b1 b2 in equation number 4 and 5. Sum of yi n b1 plus b2 sum of xi, sum of xi yi is equal to b1 sum of xi plus b2 sum of xi square. Beta 1 beta 2 represented the slope and intercept when we obtain data from population, and if we have the data from sample, uh, so we denoted these terms with b1 and b2, no other difference here. Now divide equation number 6 with respect to n. Sum of yi over n, as you know, y bar, and if we divide this term by n, n cancel with cancel, we obtain here only b1 plus b2. Sum of xi over n, summation xi over n is equal to x bar. So we obtain the term of y bar is equal to b1 plus b2 x bar, and we obtain the formula of b1 intercept is equal to y bar minus b2 x bar. So this is the mathematical formula of b1. If we want to calculate our question with respect to method of least square by using method of least square, and we obtain the intercept by using this formula, b1 is equal to y bar minus b2 x bar, where y bar is sum of y over n and x bar is sum of x over n. Now put the value of b1 in equation number 7 here. Equation number 7, sum of xi y is equal to put the value of b1, as you know, y bar sum of yi over n minus b2 sum of xi over n. For derivation purpose, we write it in this form, sum of xi plus b2 sum of xi square. So we put the value of b1 in equation number 7. Now in this step, multiply this sum of xi in this bracket. We can obtain the equation as sum of xi sum of yi over n minus b2 sum of xi whole square over n plus b2 sum of xi square. Here sum of xi yi minus, we take this term to the right side, sum of xi yi over n, this plus convert into minus when go to the this side, and we write it as b2 sum of xi square minus b2 sum of xi whole square over n. Now multiplying this term with n, n sum of xi yi, when we multiply here and this n cancel out, this n sum of xi yi is equal to b2, and on the right side take common b2. When we take common b2 means slope, sum of xi square is equal minus sum of xi whole square over n. Now we put this term to the right side, and this term go in divisor of the left side of this term, b2 is equal to n summation xi yi minus summation xi summation yi over this term, sum of xi square minus sum of xi whole square over n. So this is the formula used for to find the slope according to method of least square for regression, to obtain the best fit straight line equation. So this is the formula of intercept y b1 is equal to y bar minus b2 x bar, and this is the formula of slope n summation xi yi minus summation x summation y summation xi whole square minus summation xi whole square over n. So according by using these two formula we get the best fitted straight line of our data set. In next lecture we discuss the solved a question with the help of these formulas. Thanks.